Officially, I'd like to welcome everyone. Thank you so much for joining us this afternoon. I'm Sarah Hakey. I'm the Executive Director here with the Electrical Association of Philadelphia. And today I am joined by Matt Dybert, our Program Manager, as well as our presenter today, David Johnson with SolarEdge. I'd like to thank SolarEdge for their sponsorship of today's webinar. This was a really fun webinar to put together because I actually got to work with the team who's based out of Israel. So Efrat, thank you so much. It's been a pleasure working with you, and certainly probably one of the coolest ones I've had a chance to put together. So thank you so much. Of course, I would be remiss not to mention that SolarEdge is represented in our market by one of our members, eSite System, which, oh, that way you can see their logo here. So if you have any questions, of course, you can reach out to Scott, and that information will be provided to you after the session. Before we get started, if you've done this with us before, you know the deal, but I do want to make sure you are aware. We know we cannot see you, we cannot hear you. However, we do want to make sure that you ask and submit questions. So use the chat feature. We're going to facilitate the questions both in real time because Dave wants to make sure that any technical kinds of questions are answered right away, but also, of course, a little bit of time we'll leave at the end for any additional questions that come through. So with that, it is my pleasure to introduce our speaker. David Johnson, EIT, holds a BS in Electrical Engineering from the University of Pittsburgh and a BA in International Business and German from Grove City College. He's been dealing with power conversion and equipment since 1989 and has been in the mission critical industry space since 1997. He has over 25 years of industry experience in both static and dynamic UPS. David, take it away. Thanks so much.
Thank you very much, Sarah and Matt. I appreciate it. So in the presentation today, I'm going to share with you some key considerations for UPS or uninterruptible power systems and solar system selection. You'll leave with a practical guidance on how to differentiate between different technologies and choose the best one for your business. In addition, you'll get a glimpse into a single platform that combines all of these applications. So a little bit, hopefully, technical challenges. There we go.
You got it.
Yep, I'll have to use that one moving forward. So just a quick background on myself. Air Force, the son of an Air Force officer. I've lived around the globe. You've seen 17 locations since I was born in Okinawa, Japan. With my degrees, I started in the plastics industry in Germany, moved to Washington, PA, went to work for AEG Westinghouse Transportation, where I got my first glimpse of converters and inverters. 97, I started with Lynn Associates as an Excite Electronics rep selling UPS. Moved on to South Power Systems and AEG Power Supplies, where I eventually became National Sales Director. I got bored with that for a little bit and bought a commercial bakery, truly a factory, and ran that, plus being a business coach for about 3 years before coming back to the industry with Mitsubishi Electric, UPS, then high-tech diesel rotary UPS, and then finally on to SolarEdge, critical power. A couple key points. I think both my sons may be on here too. It's interesting they ended up in the same industry. My son Nevin works for Yale Electric Supply Company locally, and my son Christian works for Illuminations Company. An avid skier, avid scuba diver, and I love world travel. One of my favorite places is Cologne, Germany. So that's a quick overview in more detail. So we're going to give you a quick introduction and talk about cost-effective energy independence and resiliency. Again, please ask questions as they come up. We'll get into the details. So key point, and I'll come back to this, SolarEdge was established in 2006 as a startup, and we went public on the NASDAQ in 2015. As the name implies, we are in the solar industry dealing with smart inverter systems that optimize energy generation. Today, we are the #1 solar inverter company globally. We're a major player in all the solar markets and provide a full suite of products, including storage, smart energy management, EV chargers, smart home devices, etc. 4 years ago, SolarEdge went on a acquisition spree, if you will. Working kind of backwards, we bought the e-mobility division coming out of Italy, and we actually supply powertrains to Fiat Ducato commercial vehicles in Italy. Kokum is our lithium battery energy storage division. It's the largest lithium-ion company manufacturer in Korea. And then finally, the critical power division was based on a 50-year-old company, which was the pioneer of modular UPS technology, and that's the division I belong to. We look at the SolarEdge by numbers. I'm just going to concentrate on 3 numbers. Number 1, again, solar inverter company globally. Number 2, our sales in 2021, just shy of 2 billion. So from 2006 as a startup to 2021, 15 years, or in less than 15 years, we went from 0 to 2 billion in sales. And then it's covered by mine, but the patents, over 400 patents issued and 420 patents pending. First and foremost, we are a technology company with diverse R&D capabilities, a true multidisciplinary company with expertise in hardware, which includes power, magnetics, digital and analog communication and simulations, software, mechanics, which includes metals, plastics, motors, etc., chemistry and materials, and finally, automation. So we go beyond just our leading product lines. We also offer a wide range of services throughout the product's lifetime, from early stage system design at a specific site through system installation, setup and commissioning, as well as system monitoring and maintenance. In the US, we have over 400 employees, which is part of our global 4,000 plus employees. Locally, we have facilities for quick shipments, 24/7 call center, and experts across the nation. A key point here at the bottom, we have inventory. On the UPS division in Poughkeepsie, New York, I have UPSs that you can order today and I can ship tomorrow. And then for the solar inverters and optimizers, we have multiple locations throughout the US and Canada. So we do offer quick ship programs. And right now, that's a wonderful thing in this age of global supply chain issues. So let's get started where SolarEdge started on the solar side. If you get a chance, I'm assuming, host and panelists, okay. Please do fill this out. I'm just curious to see.
Keep the poll open for 5 more seconds here, so get your vote in.
So a little over 50%, 64%. So I think going forward, we're going to see a lot more of this. So let's talk about solar. Come on. There we go. So a solar system is based on solar panels, which I'm sure you all are aware of, also known as modules that produce power. Each module has an optimal working point, as illustrated in the graph, the PMPP, which is max power point. So the problem is, under various conditions, they can affect that actual point. Could be internal, like module's properties, or external, like the environment conditions, such as temperature and irradiance. So traditional systems based on a single inverter connected to solar panels that are connected to each other in series have significant limitations. Why? Each module has its own optimal working point, as you can see in the illustration here. If you only remember one thing from today's presentation, remember that module mismatch means you're losing money. Since the modules are connected in series, the weakest module will drag all of the others down to it. They will have to produce power according to its working point, which is lower than theirs. The analogy we like to use is, if you think of 4 kids running, these 4 kids are holding hands. The first one's 2-year-old, second is 4, third is 6-year-old and 8-year-old. As they're running together, they can only run as fast as that 2-year-old. So that's the problem with module mismatch. What else can cause module mismatch? Many reasons. Some can't even be seen, like micro cracks. Some are very visible, like shading. Some can be expected, like obstacles on the roof. Some cannot, like dirt and bird soiling. Some are permanent, like the damage of the module, and some are transient, like cloud shading. Some are relevant from day one, different orientations, and some will be developed in time, like differing aging rates. Even if the modules are from the same batch, delivered together, there will still be mismatch. It's just because nothing's perfect in this world. So how do you mitigate module mismatch? SolarEdge's approach is to split the functionality of a traditional inverter to smart electronics attached to every module called power optimizers, which maximize the power generation per solar panel, and a smart inverter that takes care of the conversion of power from DC to AC. The smart electronics on the module turns them into smart modules, which they can then communicate their production, so users can benefit from module level monitoring. So let's start from the result. When each module can work at its own optimal working point and does not affect every other one, every module will produce its maximum power. In this example, as I described before, with a traditional system in series, all of the kids running together, holding hands, they're going to operate at the lowest of all of the devices. While with the module level optimization, only the shaded module will be affected and all of the other ones will keep producing 100% of what they can. We call this maximum power point tracking, or MPPT. Additionally, another benefit is design flexibility. With traditional systems, different orientations are avoided to eliminate intentional mismatch. But with the module level or optimization, since the modules are independent, the layout can be in different tilts and orientation. Plus, there's an added benefit of safety. Since there are now power electronics on the module level, the modules can be disconnected if needed. Sun can never be turned off, and in case there's a fire in the building not related to the solar system, firefighters may be reluctant to go onto the roof, potentially causing a complete loss of the building. Even if they are able to shut off the inverter, there is still voltage in the cable at all times. However, in SolarEdge's modular system, they can be de-energized to a safe DC level. To summarize the benefits of the module level optimization: higher revenue, since there's no module mismatch. Each module produces its maximum potential. There's also lower expenses because the entire system is more flexible, less cabling connections. And also with module level monitoring, issues can be easily identified through remote monitoring, allowing for performance analysis and potential root cause analysis in problem modules. Imagine a solar field with direct point-to-point accuracy. And finally, the modular system solution is much safer. So not all modular systems are created alike. There's been progress over the years in the topology microinverters, which are actually small inverters at the level of the single solar panel, were a significant leap forward at the time and solved many of the limitations we reviewed. But since it's actually a complete inverter, it's a relatively expensive solution. In addition, it's an AC level solution. That means excess energy beyond the inverter's capability cannot be utilized. Then the next significant step by SolarEdge's solution, splitting the functionality of the inverter into a smart but simple inverter with far fewer components, and power optimizers, simple electronic components at the solar level. So if we look at the difference between a DC coupled versus an AC coupled system, it goes down to basically how many times you have to do power conversions. With a DC coupled system like SolarEdge, you have one power conversion. With an AC coupled system, you have not only the power conversion from your PV or your solar array, but also then to the batteries, both back and forth. So one conversion in our mind is much better than two because it is a more efficient system. Now let's move from the energy generation to energy protection. Let me walk you through the challenges we see and why the modular approach is much more effective in backup systems as well. Another quick poll for you.
We are launching the second poll now. We'll keep it up for about 20 seconds here, and then I'll share the results with David.
So quite a few familiar and a minor few that aren't. We'll go through a little of the detail here once we close out here. Give you a better idea why we actually have UPS. So IEEE Emerald book talks about 9 power problems, ranging from the power failure to sag, surge, undervoltage, overvoltage, line noise, frequency, switching, transients, and harmonics. I've said those 9 quite a few times in my career. The key point is UPS, if you look at it, is a a form of insurance. You're insuring whatever is downstream of the UPS, whether that's data, whether that's in a semiconductor application, wafers and fab, could be on the banking side, it's still data, but it's money. So it's two purposes are, number one, to avoid power failures. So it's uninterrupted. That's why it's called an uninterrupted power system. But the second function is to provide 100% power conditioning 100% of the time. So that's the role of the UPS. If we take a little closer look at it, the actual UPS in the bottom corner here, I'm just missing one component. There are four components: the rectifier, the battery, and the inverter, and then there's typically static switch bypass that wraps around. Rectifier serves to convert AC to DC, so that you have a DC bus connected to the battery, which then feeds the inverter when we're on battery, when the UPS is, when the power's gone. The inverter inverts from DC to AC, giving you a clean 100% recreated sine wave on the output. So if you have poor power on the input, through this conversion process, we're going to give you power quality on the output. And then the bypass is for emergencies, if there's a problem, or to do maintenance. So again, four basic components to an online double conversion system. I'm not going to talk about line interactive or offline. It's not something we don't offer it. And in a mission critical application where we deal, they're not used typically. So limitations of a traditional monolithic system. We take a look at the two systems here. Traditional monolithic is one large component. And if you want redundancy in that, and you have all of these components in here, also it goes to, as we'll talk about, in the maintaining of this and the repairing of it. So if you want redundancy, and we're giving an example here of 240 kW, to have redundancy in this system, you have to add another complete 240 kW module. You have N plus redundancy, and in this instance, you also have 2N. With our system, we can go with 8 30 kW modules, or anyone's modular system. In this example, we're giving you 8 30 kW modules plus a 9th one for redundancy. You have redundancy built into this same footprint. You're not adding double the footprint. We talk about redundancy and what exactly is it. So in a UPS application, N, in the old days, N was fine. N is the capacity. In our example here, N is 100 kW. But as data centers grew, as the complexity of systems grew, as banking became more digital, N was not enough, because if that failed, you had a power outage, a loss of data, loss of product, loss of whatever it may be. So we went to 2N. You had 2, or in this case, again, for a monolithic, it's 2N, but it's also N plus 1. You have to add a complete additional system to actually have a redundancy in this. In the modular approach, N plus 1, whether they're 50 kW modules or 25 kW, for 50 kW, again, our load is 100 kW. We need 2 modules to get to 100, and we have an additional 1. That's our plus 1. In a 5 by 25, we'd have 4 25s to get to the 100, and then an additional 25 kW. So that's basically what redundancy is. And again, the reason we need it nowadays is with the basically move of society to the digital age, and everything we do is digitally based. There is more need for redundancy and uptime. So with monolithic systems, looking at it, again, there's no redundancy. You're just covering, in our example, 100 kW. Parallel monolithic, we have to add an additional unit. It becomes N plus 1, but it's in reality 2N, which is a much more expensive approach. With a modular system, you can cover N. In our example, we had 240 kW, 8 times 30 gives us a 240, and we add the 9th unit for redundancy. Or if we want to go to it, we can add 2N plus 2 by going with 2 modular systems. And depending on what level of module, if you have 1 unit, it would be 2N plus 2. If you have 2 redundant units per system, it's 2N plus 4, etc. I think you get the idea. So bottom line is, when you're looking at the architecture considerations between modular and monolithic, from a maintenance standpoint, the monolithic is always going to be more challenging to maintain because of the complexity of the system and how it's built. Versus modular system, and we'll come to see that momentarily, is a much easier system to maintain. Floor space, again, from day one to your ultimate build out. With monolithic, you're going to have to leave space aside for however many monolithic units you're ultimately going to build out to. Floor space is, especially in a data center, a key component. The less floor space you have to take up for your mechanical and electrical equipment is the more space you can lease to clients. So less is better when it comes to mechanical and electrical equipment, taking up space within, again, a data center. Could be elsewhere, again, could be other ones, but data centers now are probably the most common. Cost, infrastructure, labor, investment, and future expansion, monolithic versus individual, and we'll get into some of these. And then the mitigation of risk, mean time to repair, mean time between failure, minimized load exposure during malfunctions or maintenance, and then usability of the system. With a monolithic system, one unit gives you no redundancy. In the event of a problem, an actual outage, you have the potential loss of your data downstream or loss of whatever you're protecting. So then we add redundancy. But in a monolithic system, again, we're doubling the floor space and increased cost because we're basically doubling the installation of what we're doing with one unit, but with two. Additionally, when we're building for a data center, as an example, using monolithic systems will mean we buy the equipment up front, the frame size, not the actual modules, and then we install the modules as we grow, basically pay as you grow. Put in a frame size you ultimately need, but don't populate the modules until you need them. You're ultimately saving both on CapEx and OpEx because we're not running that system. Basically, it takes power to run a UPS, and then we get into the efficiencies of them. But if we're only running, for example, let's say 10 modules versus ultimately 20 modules, and we add the modules as we need them over time, we're going to spend less money on power. Then we get into complex fault repair. On a monolithic system, many of the components can fail, and some are quite large and very heavy. And a lot of the systems I dealt with in the past were monolithic. There was, at the time, nothing wrong with them. It's today, as SolarEdge, we believe there's a better way. Additionally, you're going to need, with a monolithic system, an experienced technician and potentially an additional person to help for some of those large, for example, magnetics that need to be removed. Repairing a modular system is usually much simpler. A single module contains all the components required for its operation and is much more compact and simple. No need to guess what went wrong. You just basically replace the module. And by the way, the modules are typically, at least in our modular systems, 44 to 50 pounds each. One person can do it, and that person doesn't have to be highly trained. The system's going to tell you, module number 3 has a failure, and you'll see momentarily that's not going to cause a problem. The person that's doing the actual work, the technician, removes that module and replaces it with a new module. We can even train the end user, should they wish, on how to do this. It's very straightforward, and it doesn't require highly skilled personnel to actually achieve it. So, overcoming modular system benefits, or overcoming the challenges of monolithic to modular system: higher uptime, again, module level redundancy, loads protected during preventive maintenance, and quick module replacement, literally. Decrease expenses, inexpensive built-in redundancy, ability to increase backup power using existing infrastructure, and the ability to move modules between systems according to varying loads. That's the other beauty, just to point out. If you have multiple units of the same style, the same modules are used within them in any building. And there are a lot of times within, I keep going back to a data center, that Bay A may have more power requirements than Bay B because they haven't filled up, or there's been a change in customer. You can move modules between Bay A and Bay B, as my example. And then finally, mitigating risk. I didn't point it out, but here's a good point: automated manufacturing, module manufacturing and testing. To give you an idea how this works for us, I don't have it for last year, but in 2020, we produced over 30 million power optimizers and 2.5 million solar inverters. When you're doing that level of production, it's very simple. We've become very, very good at automation. So it allows us to not have to touch. We put it through a automated process with very minimal human interaction. In comparison to a lot of the companies I worked in the past, one in particular, I remember watching the Monolithic, you'd open it up, you'd see on a torque marking, 2 torque marks, one in black, one in green, to show that 2 people had checked the torquing of that system. Again, humans, we're not infallible, and there can be, if somebody has a bad day, there's potential for human error. So that's why we love automation, at least in the building of our modules. So with the solar system, the world of UPS systems have a variety of different solutions and topologies. There are systems that offer a certain modularity compared to monolithic systems, but the significant breakthrough comes with true modular systems. When I talk about the true modular systems, the modules are completely autonomous, meaning they have their own brains in the system. Hot swappable module replacement, and I'm talking about truly hot swappable, where you don't have to go to bypass to pull out a failed module and put a new module in. We can do this as long as you have N+1 redundancy or N+X. You can actually remove the module while the system is running. High energy density modules, I mentioned 44 pounds. We offer several different versions at the moment, depending on whether it's 122.8 or 480. Single person module replacement based on the weight, no fault propagation. If this unit fails, it's not going to cause all of the others to fail. It will take itself offline, and as long as you have redundancy, a minimum of N+1, the system will continue to function. We can have the static switch fail within the system, and it still functions without the static switch. At some point, you are going to have to replace that, but it's not going to take the system down. And on the front, there's our system controller. You can't see it here at the moment, but if that controller fails, our system continues to operate. So very robust system. Kind of pulling it all together, in conclusion, we see how the modularity principles lead to an improvement both in solar and UPS systems. So, and going one step further, when you look at the main components, both in solar and the UPS systems, there's a lot of similarity. Both systems have inverters, batteries, monitoring and communication solutions. And in both of them, as mentioned before, SolarEdge implements the modular architecture that maximizes performance. Smart energy, or as I like to call the future of energy, is smart energy. This is the glimpse we talked about, combining UPS, battery energy storage, and solar all in one application. Matt?
Thanks, David. So we're launching the poll now. Give it about 15 seconds or so for people to get their vote in.
So I'm actually pleasantly surprised. We are starting to see this in a lot of the engineering firms that I deal with. There's more and more push to combine the systems. Again, let me get back over after the poll. So the smart energy, again, combining UPS, battery energy storage, and solar all in one. Basically, we're pooling our PV or photovoltaic and charge and discharge of storage in the cloud enables new grid services and revenue streams for all stakeholders involved. Of course, the fact that we have solar systems, UPS systems, battery energy storage under one roof means we're in a unique position to develop an integrative solution, enable seamless systems with direct communications between the solar inverter and the UPS, and with optimized sophistication of utilization of battery. This is where, in my opinion, I see smart energy going, combining all of this. There's a push for green, whether it's wind or solar. We happen to be in the solar side, but combining them all together in one integrative process. So, and with us, it combines the advanced modular UPS, commercial lithium-ion storage, and the optimized solar system. So pulling it together, DC optimized solution plus assured clean power plus warranty and service, O&M, storage, battery, all under one roof. Again, smart energy. Give you an idea of one of our clients that's been moving toward this, Genome Campus in the UK. They actually had, over time, they've got 30 of our Solar Edge UPS systems. They were replacing their existing UPS system with one of our new systems after they did the evaluation. As a result, they saw an increase in the output of the system using a DC connected system. So we have several others globally, but this will give you an idea. This is, again, in my opinion, where I see things going, the combination of renewables plus battery energy storage plus turning the UPS from an expense into an asset. So my contact information is here. I welcome feedback from anyone. Questions? We didn't get any during the presentation, so I'm not sure if there are any here at the end.
Well, there's only one, and it's not quite technical, but would you be willing to share the presentation with the attendee base?
Absolutely.
Fantastic.
I'll make sure, Matt, you get the updated copy.
Oh, we see an outstanding job in the chat, David. Congratulations. Well done. Well done.
Thank you. Much appreciated. Hopefully it was of benefit to everyone in attendance.
There's a lot to digest in terms of the information, you know, that you put out for everyone. And I'm excited. I think people want to go back and watch this. The fact that you can put everything in under one roof that you talked about, to me, is very competitive, and it'll be interesting to see how, you know, how people will adopt more and more of these kinds of systems. So
agreed.
Great overview. Thank you. So a lot of wonderful responses. I don't see any specific questions. So Dave, I have to tell you, I'm sorry, can I call you Dave?
Yes, absolutely.
Oh, it's funny, your sons, both of your sons work for member companies of EAP. We were just with Illuminations last week. What are the odds?
It's yeah, it's a small world.
It is a small world, small area. Oh, I knew if we gave it enough time, we'd probably have one technical question. Matt, I'll kick it over to you.
Sure. We have a question. What is the maximum power a solar panel can provide? I'm asking to know how many you would need to support 240 kilowatt UPS.
So I'm not an expert by any means on the solar panels. On a 240, and I'll, with that said, because my background is a little heavier on the UPS side, let me talk to one of my colleagues on the UPS or on the solar side. It's not so much, it's the panels will have varying performance and varying power ratings, if you will. It's also on the inverters. How many inverters plus how many panels are you going to need to actually back up your 240 kW load? And I think to give you an example, and again, I'm just going to throw it out here. I know we're introducing our utility grade solar inverter for utility applications this year, and I believe 300 kW is, I believe, what I heard. Again, so in that case, it would be, you know, one would handle it, but I'll get a more detailed explanation. Matt, you can let me know who it is. I'll specifically, if you can provide me that question, I'll get a detailed answer for him or her.
We have another question here. Pete's raising his hand. So Pete, I'm going to allow you to talk. We can't see you, but you can go ahead and talk. What's your question? You're on mute, my friend, if you're speaking.
Good afternoon. I was just looking for a cost of material, cost sheet.
Cost in comparison, just, well, again, you're talking about, you know, are you talking about a 10 kW application, or are you talking about a 5 megawatt application? It's really going to depend. I can tell you, as an integrated system, it's going to be less expensive than a complete individual component system because it is integrated. But again, and then battery energy storage, do you want 1 hour or 10 hours? So I don't have, and if it would be nice to know, and I don't have it at the moment, $1 per kW of a combined system would be of interest. Maybe that's something we can work toward. Again, this is in the preliminary stages or infancy. And we have not only Genome, but we have several other applications in Europe where we've implemented this, a hospital in London, and I believe a soccer stadium in Austria. You know, as we move forward, and we will be implementing a case study here in North America as well going forward. So we'll have, again, it's infancy, so I don't have specific data on $ per kW on a complete system, but we will get there.
So we'll certainly make sure to connect you and Pete and probably Scott, you know, just to kind of follow up if there's more specific details Pete can provide to you. So thanks, Pete. All right. With that, Matt, are there any more questions that you can see?
There are not.
All right. Well, David, go ahead. Did you
I was
have
going to
something
say,
else?
thank everyone for taking the time out, especially on a lunch hour on a beautiful Thursday afternoon. I do appreciate it.
Well, and thank you. This is great information. And if anyone's so inclined, you can come meet David, learn a little bit more about Solar Edge at our upcoming trade show this fall. It's a shameless plug, I know, but we'll see you in October.
No, Electric Expo 2022. I'm looking forward to it.
Exactly. We'll see you this fall. Everyone have a great afternoon. Thanks so much. Take care.
Thank you.
Bye-bye.